So I just said that sodium chloride is made by a sodium ion and a chlorine ion bonding together, which of course leads to the question, what's a chemical bond? Well, chemical bonds are not mysterious. They're just forces that cause atoms to stick together. Now, chemical bonds hold chemical potential energy. We use chemical potential energy in everyday life when we burn fuel to make our cars move, or we use batteries for electricity, or even in the food we eat, we're getting chemical potential energy stored in the bonds. And so what happens to get the energy out is we break these bonds apart and then form new bonds that have a lower energy stored in them, and that excess energy we use. So chemical potential energy is energy stored in chemical bonds, or energy stored in the attractions between atoms or ions. Now, we know atoms form bonds because they're trying to reach a stable electron configuration, and that means get to 8 valence electrons most of the time, trying to fill the s&p energy, or s&p orbitals. And so that's the octet rule. Only atoms over here in the noble gases, they don't form bonds, right? Everything else will. And so one of the ways they do that is by forming ionic bonds. And an ionic bond is when valence electrons are transferred, that is to say moved, from one element to another. When that happens, we end up with oppositely charged ions, right? So over here we start with sodium, which was a 0 net charge, and chlorine, which has a 0 net charge. But then this electron from sodium actually moves over there, which results in a positive ion and a negative ion, and opposite charges will attract. So the oppositely charged ions stick together. That force of attraction is a chemical bond. So now we have an ionic compound that's held together by an ionic bond. An ionic compound then will always have a positive ion and a negative ion, and since we know positive ions form from metals and negative ions form from nonmetals, ionic compounds will be composed of metals and nonmetals. Now, once these two things have transferred electrons, they're no longer the same things that they used to be. Their properties will be different. So atoms change their properties when they form ions and bonds, and so we end up with things we don't start with, although we still have the same nuclei floating around. We haven't had any nuclear changes. So sodium is this silvery shiny metal. It's very reactive. If you were to hold it in your hand, it would react with the water in your hand and it would burn. Chlorine is a very reactive gas. You breathe it in, it could be one of the last things you do. But you react the two together and you get sodium chloride, which is just table salt. We eat it every day, right? Salt is not a metal. It's not a gas. It's salt. It's this brand new compound with its own different properties. Ionic compounds have their own set of properties that they generally have. They break when they're struck, that is, they're brittle. And that's because if you see down here, there's a negative next to a positive, next to a negative, next to a positive. So every negative is surrounded by positives, but also every positive, right, here's our positive, it's surrounded by negatives, and here's a negative, it's surrounded by positives. That structure makes these things very, very hard. It also makes them brittle, because if I strike this and I misalign them, now I have negatives next to negatives, and this thing will actually break apart. It'll shatter. It also means that these things are fairly poor conductors of electricity, because these particles are locked in position and can't move, unless of course you melt it or dissolve it, and then you have charged particles that can move. It also means it's going to be pretty hard to melt them. They got to get really, really hot, because there's a strong force of attraction holding those particles together. So they dissolve pretty well because that allows us to have moving charges, and water likes charged particles. We'll look about that more later, but when you drop salt in water, it separates the ions, and then we have conductors because those ions are free to move around. The more ions, the better the solution is going to conduct electricity, because the more charges there are to transport it.